I'm David Fernandez. I am currently working at Proceq, or Screening Eagle Technologies, as product manager. And I'm responsible of 3 products of the company. One of them is the PI, the Pundit PI8000, which is the one I'm going to talk about today. And I have also in my portfolio 2 other devices. One is called Resipod, that is used to measure the resistivity of the concrete. And then we have the profometer corrosion, which is also very useful to estimate the corrosion likelihood of the concrete element. So today, I want to talk about Impact Echo, which is one of the applications that we recently launched since last 27 of June. And this webinar is going to be focused mainly in this particular technology. So I forgot to mention that at the very end, we will have a round of questions. So if you want to have some questions, you can do it. Just press the button of QA button that you have here in Zoom, and then I will happily respond your question at the very end of the presentation. Okay. So it's going to start with a quick introduction on the market, their needs, and why we think this product is going to be really useful for our future clients. So we have the concrete market in the civil infrastructure, and this is a very, very big or huge market. As every year, around 20 billion tons are built of new concrete. So you can imagine how big is this market worldwide. And it's a very important one. And then in this market, I like to just to separate the civil structure in 2 different parts, because you will see our device is doing it has 2 different features. So that's why I think it's important to differentiate. So we have the above grade structure. So there we have buildings, we have airports, highways, harbors, any kind of civil infrastructure you may have above the grade level. And then we have the below grade structure. So as an example, we have tunnels, we have foundations, retaining walls, metro, subway. You can imagine there are a lot of different types. And another topic which is really important is that concrete integrity inspections are vital. So you know, the concrete has a lot of defects, long-term defects, that are normally visible later on after some years of the initial construction. The most common ones are the laminations, also internal and external cracks. Then you can also have corrosion that normally causes also the laminations, honeycombs, etc. So that's why it's so important to prevent these damages that are going to affect the structural integrity by inspecting this infrastructure regularly, right? One of the main problems that some users may have is the estimation of the thickness whenever they want to refurbish an existing building, for instance. They want to know the thickness of a particular slab. So there's some destructive methods, such as the one that is in the image. So you can drill a hole inside this concrete element, and then you can use a measuring tape to measure the total thickness of the element. But of course, this method is intrusive. You're going to need to repair the concrete afterwards. Then it's also time consuming, and it's costly. It's a costly system because you can affect one of the inner rebars. And just for the estimation of the integrity, a good option is to extract concrete cores. And by visual inspection, you can see if there are some internal defects, as you can see on the image. But again, this is a destructive technique. And it's really accurate because you can see visually the defects, but the problem is that we need to repair the concrete voids afterwards. So that's where Impact Echo testing is a really good alternative, because it's a non-destructive technique and it's also fast and inexpensive. So this is a very good technique if you want to avoid these non-destructive techniques that I was talking before. And then on the other side, as I talked before about below grade infrastructure, we have the foundation piles, which are normally used as a foundation for big buildings, whenever we have a soil that is not really strong. So then we normally have this shallow foundation, or this deep foundation, which is the opposite to the shallow foundation. And the main problem here is that there are three techniques that are quite well known, but are expensive and they require normally advanced preparation. So we have the static load test, which is normally required to test some of the piles that you are constructing, but it's very intrusive and you need huge auxiliary members. And then this is similar to the dynamic load test. And lastly, we have the cross-hole solid lodging, which is kind of a non-destructive technique, but it requires to just to place some embedded tubes inside of the pile prior the casting of the pile. So you can just insert these cables with the sensors on it. So here again, we offer this a different technology with the same sensor, which is the lowest strength pile integrity, which is also non-destructive, it's fast, inexpensive, and you don't need to prepare to do any kind of preparation in advance. So whenever you have finalized the pile, after some days, you can test it with our system. So let's go to the product overview. This is a quick video of Impact Echo mainly. You can see. Okay, so this is the promotional video we have on our page. And it more or less tell you how fast is this test, but we will do later a demo with my iPad. So one topic I would like to talk about, this is one sensor. With just one sensor, we have two different applications. Both of them are for the estimation of the concrete integrity, but on one side we have we can test piles or foundation piles. So you can estimate the total length of the pile and also to detect internal defects. And on the other side, we can test walls and slabs. So we can find the thickness, we can detect the thickness and find internal defects. So the webinar today is I'm gonna focus on Impact Echo test. The pile integrity test is something that we already released since last summer, 2021. And this is the testing to estimate the integrity of the piles. But today I would like to focus more on Impact Echo, which is the new software release that was released the 27th of June, about 1 week and a half ago. And this is a new software release, and we have an advanced hardware with a different tip, which is giving us even better results. So just focusing on Impact Echo test, we have there are three main elements. On one hand, we have the hardware, which is the sensor with an accelerometer inside. Then we have the three impactors, small impactors, and then we need an iPad to download the app from the Apple Store. And this is a quick overview about how good is this system for the client, because we increase the user experience. We make a better user experience. Why? Because we have real-time data acquisition. Then we also provide real-time data visualization on the iPad. And then the thickness of the element is automatically selected by the app. Also, we increase by 3 the productivity. Why? Because first of all, we have a dry contact test. Not all devices from the competitors are like that. So you normally need to use a coupling material, which is something that is sticky. And whenever you are moving the sensor from one spot to the next one, you have to put again or just to remove again the coupling. In our case, it's not like that because we perform dry contact test. So you don't need to use any kind of coupling agent. And also, it's important to note that as this system is fully online, so as you are connecting your probe via Bluetooth with the iPad, all your data is going to be stored on the cloud. So then it's pretty easy to create reports and also to collaborate with your offsite colleagues because you can share anytime the data in real time. Then we have a feature which is comparison that allow us to just to improve also the productivity, of course, because we have this review mode that I will explain later, and also we have a grid mode that I will also explain later, and the best impact is automatically detected. So what kind of elements we can test with this technology? Because this is a very wide technology that can be used in many different for many different functionalities. So we have these horizontal elements and vertical elements, and any kind of curved elements, you can also test them. So for the horizontal elements, I have here some examples, but you may find some others in your daily work. So we have slab on grade, we can have foundation slabs, any kind of flooring inside the building, bridge deck, any kind of beams. This one is for a concrete bridge, but you can also test beams on a building, and concrete pavement. For the vertical elements, we have internal building walls. We can also have retaining walls in a highway, or also tunnel linings. So any kind of these concrete elements which have a shape of a structural plate can be tested with this Impact Echo methodology. So the preparation is really important. There is some limitations of this system. The first one is that you need to test over a concrete plate. What I mean with that is that the minimum length has to be at least 6 times the thickness of the element. That means that you need to test this kind of slabs or walls, as I was showing in the previous two slides. And this is because if you are testing very near the boundaries, very near the edges or the sides of the element, you may have some boundary effects because you may get some reflection from the sides, and sometimes it's complicated to understand completely the signal. So this is a recommendation, but of course there's some advanced users, Impact Echo users, that also test over concrete columns and concrete beams. But you need to be a little bit more advanced on this technology. As I said before, we perform dry contact solution, so you don't need to use any coupling agent. But in any case, the surface of the concrete has to be smooth and clean. And we are providing some stickers, plastic stickers that you can place over the sensor tip, just in case you are not getting a good signal because the concrete is not completely smooth. You can always place those stickers that remains on the tip for a very long time, and then you just place them there once, and you can use it as many times as you want to. So this is very quick and very convenient. And then for the measurement location, you either have to decide if you want to perform a spot test or a grid test. I will explain later what are the main differences. And as I said before, the best impact that you perform per spot is automatically selected by the app. So this is also really good and really convenient because you don't need to pay a lot of attention on the impacts you are performing. So how this works, how this Impact Echo technology is working. So this is relying on an acoustic wave, which is also an stress wave. So that's why we need to use this hammer or impactors just to make an impact on the concrete surface, and then you will see that the wave, the sound wave, is traveling through the concrete and then going backwards to reach the sensor accelerometer. And one important note is that this technology relies on the impedance. So the impedance, which is a material property, is really different, the impedance of the air, if you compare it with the impedance of the concrete. And that's why normally the air, normally not always, the air is reflecting 100% of the signal. So that's why it's a very, very useful technique to detect the back wall, as this is the case, or internal voids or defects that you may have. So as we are having an accelerometer on the bottom of the sensor, we will have this time domain graphic, which is a graphic that is not very useful for the for the user. For the advanced user, it's useful, but if you are not very advanced, it's much easier to understand, just to go to the frequency domain graphic. So what we apply is a fast Fourier transformation, which is a mathematical procedure. And then it's easier because you just need to check what is the peak, where is the peak, frequency peak in this graphic. And just by applying this easy formula, you know, by knowing the speed of the sound inside of the concrete, I will talk about this later, and also the frequency, you are able to detect the thickness of the element. This is not a formula you need to do or to apply, because this is something we do automatically with our app. So again, this is the test principle for a concrete thickness. And then when we are testing over a big delamination, what is normally happening is that you're going to have a higher frequency. And then the thickness, of course, or the location of this delamination is smaller, right? This is not always so easy, because this depends a lot. I mean, this technique is quite a little bit complicated at the very beginning to understand. And it's not like that all the time, because it depends on how big is this defect or this crack. On the left side, you have the normal thickness frequency, which is called FT. Then if we have a very small crack inside, what is going to happen is that no reflection is going to be done by the void. However, all the signal, the wave signal, is going to travel, and then it's going to go back. What is happening here is that the distance that the wave has traveled is a little bit bigger, and that's why the frequency is smaller. So then you will see a peak shifted to the left. Then if we have a little bigger crack inside, we are going to have also a shifted peak about that is showing the wave that has been able to travel to the end of the back wall of the element. But then we are also going to see a small flow peak, which is showing the frequency of this the position of this crack. And for bigger cracks, we may have also a self-resonance issue, or not issue, a self-resonance frequency about this delaminated part. So then we will have this flexural mode at the very low frequency, and we will be able to see also the frequency peak of the flow. So this is more or less, this is a very important slide. Once you understand this slide, you are much more better in the interpretation of the signal. So that's why I decided to place it here and to explain it here. Then one very important topic is the calibration of the wave velocity. So this technology is standardized on Impact Echo is standardized in the ASTM. The 1383 is also standardized in a German guideline. So there are three different methodologies that are covered by this standard for the calibration of the velocity. One of them is the automatic calibration. For that, you need two transducers that you need to put one separate from the other around 300 millimeters. This is something we don't provide with this first version of the sensor, because it requires two transducers and it's much more expensive. It's almost double price. So we decided to provide the manual mode, which is also really good, because you only need one transducer or one probe, and then you just need to go to one element that you know the thickness, right? So just imagine you know the thickness of one particular concrete slab. Then the only thing you need to do is you just input here the expected thickness of this element. Let's say it's 200 millimeters. And then there are two different options to calibrate. One is manual and the other one is automatic. So either you just, I will just show you later in a video, but you can scroll this velocity slider until you match in the peak. You see there is a thickness number. So you have to make it match with the expected thickness, right? And this is let's say the more manual way to do it. But then if you don't want to do that and you just want to know the SAT velocity speed number, you just press calibration button and the app will do it automatically for you. We will see it later in the video in more detail. So this is again, and if you want to detect, this is just once you have calibrated the device and the wave of the speed, the wave of the sound, I mean, then you can test any spot as you want to. And then as the speed has been already calibrated, you don't need to do it again. And then anytime you are testing, you will automatically receive the thickness of the element. So imagine that you are receiving all the time around 580 millimeters as this in this example, and then in the next spot of the same concrete element, you just receive a smaller or a bigger frequency. So that means there is a defect for sure in there. So then you can do a more detailed grid scan in this particular location. And then maybe afterwards, you want to expose the area to see if there is an inner crack or not. So we have two different measurement modes. One of them is called the spot mode, and the other one is the grid mode. So for the spot mode is really useful for quick concrete integrity check of small areas. So you can define various spots. Then you can also make multiple impacts per spot. You can delete any spot if you need it. Then you can also delete any impact if you need it. In some cases, you may perform a wrong impact, so you can always delete it, so you don't have any fake data. And then, as I said, the best impact per series is automatically detected by the app, and all the calculations are done by using this particular impact. Then we provide two different buttons to arm and disarm the probe. You can either use the iPad button, or if you want to just use only the sensor and just not to pay attention to the iPad, you can always use the button on the sensor itself, which is really handy and convenient. So let me show you a video about the spot mode. So then you have here the three different methods: the pile integrity, which was launched last summer, and the two new measurement modes. Then I'm gonna select the Impact Echo spot mode. And then first, as we have three impactors, you can select the impactor that you are gonna use. And then you can input the expected thickness. So let's say we have a 500 millimeter element. Then we can start just making some impacts. Then you see that this number doesn't match with the expected thickness, so that's why you need to calibrate. Either you can press this button, the calibration button, or you can play with the velocity slider, right? So this is more or less what I'm gonna do in here in this video. So until what you have to do is to make it match, to make this peak match with this 500 millimeters. Okay. And for the grid mode, this is more interesting when you want to scan larger areas. So you can create a two-dimensional grid scan. You can always define the grid spacing. So you can define the horizontal dimensions and the vertical dimensions that can be different. No, it doesn't have to be a square as it is in this example. And then once you have finalized it, you will have a thickness heat map. So in this particular example, you see that our concrete element has a thickness around 180 millimeters. So it's very likely that this area has any kind of defect, as we are not getting the same signal. And then we provide two different customized color range. And it's the same as with the spot mode. You can perform multiple impacts per spot, and then you can delete any impact if needed or any spot if you need it. So again, I'm gonna present this video. So this is a grid scan that I did the other day. This is already completed. So I can just go to A1, from A1 to C1. So I can move from one cell to the next one. Then I can see the different impacts that I have done per cell. If I just use my two fingers, I use two fingers swiping up in the iPad, then I will go to this visualization of the time domain and the frequency domain. And then again, here, I also can play just to calibrate a little bit. So this example is a good one to see that maybe in this area, I mean, it should be around 180 millimeters. So maybe in the area that is orange, we may have some minor problems because we are having a peak that is a little bit shifted, right? And we saw before when you have a small shift on the frequency peak, it's very likely you have a small defects inside. So then you can play always with the color ranges. Okay. So then we have a lot of additional settings that are really good for not only for expert users, but also for new non-expert users. So we have this auto gain functionality. We do automatically do this transformation from time domain to frequency domain. Of course, as I said, no, the frequency domain is easier to understand than the time domain graphic. Also, this peak on the frequency domain graphic is automatically detected. So then you will have automatically the thickness of the element. And we have these very useful high and low pass filters that are very good to eliminate the noise on the very low frequency or high frequency areas. And you have this full control of the filters that can be applied to all spots. So once you have set the filters, they will apply to the future spots you are testing. And finally, we have this comparison mode. So you can compare the different impacts per spot. So you can neglect one of the impacts. Yes, this sample is really good because we have this blue small signal on the bottom that is pretty sure this is an incorrect or a mistaken impact. Maybe I just make an impact on the sensor or whatever. So I can delete this impact, which is the number one, is the one that is highlighted. I can press in the number one, long press, and then I can delete the impact. So it's no longer there. And finally, as in other Screening Eagle technology apps, this is very similar for the reporting and the logbook. So we have different formats available for the reporting, and then we also have the instant collaboration. You can export the waveforms. You can make some pictures and export them. You can also make some marks, some notes, and export them, and some other comments like audible comments or written comments. And also GPS positions are gonna be safe. So you will allocate all the testing in the sub position. So before we proceed, I would like to just to do a demo right now with my iPad. So let me share the screen 1 second. So I'm gonna need like 10 seconds. Okay, 1 second, because I'm gonna share my screen on the iPad. Okay, so it should be there, right? So this is Pundit Impact. Let's go back. So first of all, what you will see is this page, which is the front page. Then I need to connect my probe. Is this one? I have it here. So then I just turn it on. Okay, and then I can go here, press, and it's already connected via Bluetooth. Then I can create a new measurement, a new file. Yeah, it's important to know that I'm gonna just make the impacts on my table. So the signal that I'm gonna receive is not a real signal that you will normally receive whenever you are testing a concrete element. So I just place the sensor on the table. Then I make one impact. Sorry, I had to press the button. Yes, now I make the impact. Second impact, third impact, impacts. It's completely real time. Then I'm gonna show you later like a demo file that I did yesterday, because this signal makes no sense as I am testing over a good table. But this is just to let you to play with this, so you see how fast is the acquisition of the data. So then if I don't like one of the impacts, I can delete it. Then I can create a new spot, right? So I can just make again some impacts. Okay, so just imagine the thickness of this element, let's say, is 300 millimeters, right? And then you see here it said is 303 Cs. So then this is because the velocity is not calibrated, right? So I can move it here manually, this scroll, right? Or better, I just click calibrate, and then you see now it's 300 millimeters that match with the expected thickness, and it's telling me that this velocity is 1,526 meters per second, right? This doesn't make sense because, as I said, I was just testing on my table. but this is just for you to see how it works. Also, we have these high pass filters, right? And the low pass filters, so you can play with the graphic a lot. And then we have also the imperial units or metric units. So I would say most of you are from America right now, the ones that are joining this webinar. So I can just put it on imperial units. So I have the units on inches. And then I can create any comments here. I can also play with the audio comments or make a picture, right? So let's say make a picture. Okay, so this photo is gonna be there. And then you have the logbook, which is really good. It's just for traceability about what you have done with this particular test. So you see, this is the location. Right now, I am in my house in Malaga, Spain. And then you can see everything that I have done before. So the traceability is really good. So just let me show you quickly one example, real example. So for instance, the bridge. So this is a bridge that is nearby my house. I would like to show you some pictures so you have an idea. Okay, so this is the bridge, and I was testing this concrete column, which is a hollow concrete column. So I was testing in the front face and in the side face of the column. So that's why I have two spots, right? So on the first spot, you can see here, this is a more normal graphic that you will normally see whenever you are doing Impact Echo. So this is around 13 inches thickness. So just let me go back to millimeters just in case some of you. Okay, so this is a 325 millimeters, which is a normal thickness of this kind of elements. And then I can go to the spot 2. And this area is thinner, sorry. So you see this area is around 200 millimeters. And as you see, all the impacts are more or less similar. That means there is not internal defect in here. And then I want to present also a demo file of a grid scan that I did. This one, for instance, okay. So that one, it was a wall. I don't think I have the picture, but it's a retaining wall in my office. And then it was 250 millimeters. I was able to measure the thickness because the top of the wall was visible. So you see, this wall is perfect. Here, I can select 250 millimeters. And then you see everything is green, which means the thickness of this element is always the same, meaning that there is no internal defect. So again, here I can select the impacts that I was doing. And then if I just swipe my two fingers up, I can go to this time domain and frequency domain graphic. So I can press any of the cells, and then I can see like individually each of these cells. Okay, so let me go back to the presentation. All right. So I think this has been more or less useful for you, I hope. And this is a summarize. So for what is this technology? We have already talked about this, but I would like to summarize everything. So this is just to estimate the concrete integrity for walls and slabs. You can measure the thickness and you can locate any kind of internal defects. So you can use it to detect delamination, honeycombs, flaws, voids, bondings, cracks. And also it has been used, we have some clients using it to detect voids inside precast ducts. So this is also a technique that is applied. And the required conditions, as I said before, dry contact measurements, so no coupling agent is needed. It's normally used with a direct contact over the concrete. But I know some people that they also use it over asphalt overlays, but it normally works better if you are testing concrete elements. And this is very useful for small areas to cover. You want to do a huge scan of a bridge. We have some other concrete sensors in our portfolio. That's why I would like to present also in this slide the PD8050, which is a different sensor in our portfolio. Some of you may know it. And this is, of course, a more powerful tool whenever you want to do a bigger scan, because it's faster and also the visualization of the data is more powerful. But in any case, the PI8000 is really useful for just to check a spot and small areas. It's a very light and quick device for concrete integrity inspections. And as you saw, it's really, really easy and really quick. And it's really good when you have areas with a lot of rebars, because this methodology relies on the impedance, as I said before, and the impedance of the steel is similar to the impedance of the concrete. So if you have a lot of rebars, the wave of the sun will travel through those rebars, and then you will be able to detect voids below those rebars. So this is a very useful tool for that. And these are standardized in the STM. So this always means that, if this is standardized, it's easier that you can use it for a particular client, because it's standardized in the STM standards. And as I said, it can be used for pipe integrity testing. So this is a 2-in-1 device, which is also very, very useful. Okay. And the PD8050 on the other side, as I said, is a very useful and powerful machine for bigger scan areas. The visualization is easier because it has a powerful 2D and 3D imaging, which is easier to interpret if you are not an advanced user. And we also offer in this device augmented reality heat map to indicate these weak areas. So as I said, this device, PI8000, is standardized. When we are talking about pipe integrity test, we have this standard, the D5852. And for impact echo technique, we have this German guideline and also the STM C1383. Then it's gonna have a quick overview of the sensor. So we have this button to arm and disarm the device, and the accelerometer, which is located on the bottom of the sensor. And then we have this USB-C cable to connect with the computer, just in case you need to update the firmware. We have the Bluetooth dongle. This is relying on Bluetooth technology to connect to the iPad, and the battery is a AA battery. And this is a rechargeable battery, but you can always use your own batteries here. So as you can see in the image how small it is, if you can see me, right? So it's very small, and the impactors are like that, okay? Okay, so we have 3 impactors, as I said. The smaller one is useful when you want to check thinner elements and superficial defects, because it creates a high frequency wave which has less penetration but much more accuracy. Not accuracy, but I would say much more, I don't know how to say this, let's say accuracy. And for the bigger impactor, it provides a lower frequency, which has more penetration, but is less accurate than the smaller one. So the biggest one is really useful if you want to test like a thicker elements. Okay, then here we have the data sheet of the Pundit PI8000. And I don't want to go in detail in here. We are gonna share this slide, so you can always have a look at this. But as you see, it's a very small device with one standard AA battery, and also it's very light. It's 144 grams. So this is a very handy device. And the datasheet of the app, which is now the version 2.0.0, that you can always download it from the Apple Store. And if you have an iPad, we have the app is for free. So then you have a subscription model that I will explain later. But the app, you can download it, and we have some demo files, so you can have a look at them and play with them if you want to. Then we have workspace, which is our environment where we connect all of our sensors. So all the sensors that we have with an iPad app are connected to this workspace. So this is very important for cloud connectivity because all the data of your sensors are going to be linked to this workspace environment. So you don't need to use the iPad all times. You can use your computer or your phone or whatever you want to use. You just need to log in into your Screening Eagle account, and then you will see all the data. As you can see here, this is one example of my data. It's an old picture because the data is from February, but you can see here I have all my files, and I can see the logbook as we saw before, and then just by clicking here, then clicking more, I can also share this information with anybody and export the information to create some reports. Okay, and just to go quickly over the value proposition, even though we have already talked about most of the topics. So we offer dry contact to speed up the data acquisition. This is really, really important whenever you want to do a lot of spot testing, because if you need to use this coupling agent, you will need to remove the coupling from the wall and then to place it in the next spot. This is quite annoying sometimes, so that's why we decided to upgrade our system and not to need this putty or this coupling agent, and you can perform this dry contact measurement quite faster. Then we have the automatic selection of the best impact per area that brings you accuracy and repeatability, and also the signal transformation from time domain to frequency domain. Again, this is really useful to make you understand better the data. Then the quick thickness detection also with the frequency dominant peak, very useful to do this quick testing. And I think I said that before already, but this grid visualization is completely customizable. So this is also very good for the users. And we have this thickness heat map with two different color ranges for facilitating the interpretation. Okay, so just as a conclusion, we have two applications in one device. So remember, we can use this app in pile integrity testing and in impact echo testing. So if you are a user that do normally, or your company do normally both test, you don't need to buy two different sensors, because we are the only product in the market that is able to perform both tests with the same probe, with the same sensor, with the same app. So this is really good because it's a huge cost savings, and it also allows you to reduce the inventory. And then the workflow is completely optimized because you can do the analysis in the field or in the site, in the construction site. We have a simplified entry of measurement locations, and the completion of the fieldwork is much faster, and you will do less errors. This is because you can always share real time the data that you are collecting to your boss or to your superior or to the analyst. So maybe this analyst will like you to perform an additional spot testing. So then you don't need to go away from the construction site, because the communication is really fluent. And then, this saves a lot of time and money, of course. Then we have a superior software user experience, because we record really fast the site parameters, as you saw before. We have this real-time data visualization, and also it's very easy to create reports. You can also create reports directly on site. And finally, versatility and comfort. I have mentioned it like 3 times already, but we have this dry contact for faster data acquisition. Then we have, I didn't talk about this, but the sensor is completely wireless. So there is no cables at all. So you can connect the sensor with the iPad via Bluetooth, and then you don't need to use any cable. So this is very, very good because you can perform any kind of impact echo test with just one operator. So you only need one man to be on the site, and you are saving, of course, a lot of money. You don't need to hire 2 people to go to the place, to the site. And this is all that I have from my side. So now I'm gonna have a look if we have some questions. So let me go back to 1 second. Okay. So I see there are some questions. Okay, just give me 1 moment. I'm collecting them. So, okay, the first question is, what is the maximum penetration I can reach with this product? So that's really a good question. We had a webinar this morning and somebody asked something similar as well. So that depends a lot on the concrete quality. But I would say, and also on the side of the hammer or the impactor that you are using. But as I said, you need to use the bigger impactor to go deeper. You will have less resolution, but you will have more penetration. But in any case, I would say a normal application would be around a maximum penetration of 60 to 80 centimeters. Okay. Another question, what is the accuracy of the product? So, okay, this is also a good question. The accuracy is around, it depends a lot also in the calibration of the speed. So if you perform a good calibration of the speed, just imagine you have a 2-side accessible element and you know the thickness of the element, then the calibration of the speed is gonna be perfect. The accuracy of the measurements are gonna be around 2% of the thickness. So if you have, let's say, 200 millimeter thickness, then you may have an error of 4 millimeter, which is really, really small. Okay, let's go to another question. Is it possible to detect air voids in post-tensioning that? Of course, it's possible. Indeed, we have some clients that are performing this kind of test. I think I already mentioned in the webinar. So as I said, the impedance of the steel is similar to the impedance of the concrete. That means that the signal is not changed by the system of this of the cable, no, of the precast cable. But whenever you are encountering or finding a void, you are gonna see it on the frequency shift. So this is pretty easy to find. Okay, let me check if we have. Okay, another question. Can you create a cylindrical grid? This is a good question. You cannot create a cylindrical grid right now, but right now you can create either a square grid or a rectangular grid. But you can play with the grid. You can jump some cells. So you don't need to perform impacts in any cells. You can just use your finger and go to a particular cell. So I would say you could do this cylindrical manually, right? But we will have a look at that. Maybe in a future release we can implement that. Another question. Can data from PI be exported to InSpec? So this is on the roadmap. It's not available right now, I would say. But of course, I would say most of the spring nickel technologies sensor are gonna go to InSpec. So for sure we will have it soon. Can I test with PI8000 and other materials such as ceramic or wood? Well, so this technology is mainly used for I would say for concrete. I know that there are some people using it in asphalt layers. Then also you have a look at the Impact Echo book, which is a really good book. You will see that this is also a technology that can be used in CMU walls. I have never done a test like that myself, but it said that it can be used. Then it depends. We never do a test in wood. I would say it could work. You will need to, of course, to just to calibrate the speed, which I assume is different than the concrete. But this is something I cannot. I don't know. Another question is Okay, this is a good question. The yearly fee, I assume he's talking about subscription fee, is on top of the integrity test fee. No. So this fee that I was talking, the 1,200 Swiss francs, is for both applications. So whenever you are paying for this subscription, so you will be able to use the complete app. So you have three measurement modes. You have pile integrity mode, then you have Impact Echo mode, Impact Echo Spot mode, and Impact Echo Grid mode. So this is for the same price. You have the two applications, right? Two applications in one. Okay, so another question. This is a good one. 60 to 80 centimeters in Impact Echo mode for slab testing. It said for pile measurement mode is much deeper. So that's correct, and this is a different, even though we are using the same sensor, we are using completely different frequencies. That's why we are using the small impactors for the Impact Echo mode, and we are using the big impactors for the big hammer for the pile integrity method. So with the big impactor for the pile integrity method, we are having a very low frequency wave, which is much more able to penetrate really, really deep. But as I said, the accuracy is less. So for Impact Echo, the frequency, the recommended frequency is higher, and that's why you need to use smaller impactors. You can always try to use a bigger impactor just to try to expand or to extend this limitation of 80 centimeters. But I would say most of the occasions, maximum penetration you're gonna reach is 1 meter. Okay. Okay, another question. This is a good one. Can you also test dry contact for pile integrity test? You can always try. You can always try to do that, but I would then suggest to do it because you normally, whenever you have a concrete pile, the top of the pile, the head of the pile is normally, it's not smooth. It's really, it's normally destroyed. No, the concrete is not really grinded. So that's why you need to use putty. That is this piece of like a sticky material that we also include with our kit. And in these particular cases, for pile integrity, I will always recommend to use this sticky material. You're gonna have a much better signal. And in this particular case, you don't need to go from one point to the next one. You will go from one pile to the next pile, but you're not gonna perform as many impacts as with Impact Echo test. Yes, another question. Can I use the PI8000 to test for rigid concrete pavement? That's correct. As you are testing concrete, this is one of the applications that we can cover with PI. And I think these are all the questions that I have. I was just double checking. Okay, so we are on time and I was able to respond all the questions. I'm happy for that. So yes, I do really appreciate that all of you have joined the webinar. And if you have some additional doubts, you can always contact me or Screening Eagle Technologies. So I do really appreciate that you have joined and have a good day. Goodbye.